What if your gadgets could last forever? I mean, really, what if the smartphone in your hand wasn't just destined for a drawer, or worse, a landfill? We're surrounded by some pretty magical tech these days. Phones that fold, sensors that can curve, tech that literally feels like a second skin. It's an incredible leap forward, but all this progress? It has a sharp, hidden cost.
And here's the reality check, 70%. That's how much of all the toxic heavy metals found in our landfills, we're talking nasty stuff like mercury and cadmium, comes from discarded electronics. So the very same innovation that's connecting us all is also contaminating our planet at a pretty alarming rate. That's the paradox we've got to solve.
And that's exactly where we're heading today. We're going to explore how the very same flexible technology that's creating this challenge is also, believe it or not, unlocking some brilliant solutions to one of the biggest environmental problems of our time: electronic waste.
So, we're kinda at a crossroads, right? We all want the sleek, bendable gadgets, but are we just creating a future of flexible, disposable waste? The numbers, well, they're pretty staggering.
Just think about this. Way back in 2009, in the US alone, 141 million mobile devices were thrown away. And out of that huge mountain of electronics, only about 12 million were actually collected for recycling. And that was over a decade ago. Our appetite for new tech has only gotten bigger since then.
So why is this so difficult? I mean, why can't we just recycle them? Well, it's because these flexible circuits are an absolute recycling nightmare. They're not just bendy versions of the old green boards. They're more like a complex jigsaw puzzle where all the pieces have been superglued together. Let's break it down. A flexible circuit is basically a sandwich of different materials. You've got a plastic base, some ultra-thin copper wiring, and it's all held together with these ridiculously strong adhesives and a protective film. The problem is, these layers are fused so tightly that trying to tear them apart to get at the valuable stuff inside, it's like trying to unbake a cake. It's just not gonna happen. As one source puts it, it's a material cocktail that laughs at conventional shredders. You can't just grind it up and pull out the good metals. You just end up with a useless, contaminated powder. But what if we could actually design our way out of this mess?
Okay, let's dive in, because this is where the really genius solutions start to pop up. The first big idea isn't about building better shredders. It's about creating electronics that are actually designed to be taken apart, right from the very beginning.
So, say hello to the Reuse project from the UK's National Physical Laboratory. These guys completely rethought how a circuit is built. Instead of using permanent, indestructible bonds, they developed these special polymer adhesives that hold everything together perfectly during the device's life. But they have a secret weakness.
And here is the elegant part. The trigger to unlock this secret weakness isn't some harsh chemical or a complex, expensive machine. It's just hot water. Seriously, a simple bath is all it takes to kick off the whole process. And the result is pretty remarkable. The adhesives just dissolve, and the layers, they just separate. The valuable chips pop right off, totally preserved and ready to be used again. The entire circuit is literally unzipped.
And the efficiency is just incredible. Over 95% of the structure can be recovered. Think about that for a second. We're talking about a phone where almost every single part is ready to become part of the next model. That dramatically cuts down on mining and waste. It's a massive leap forward. But unzipping is just one approach.
So, what if we went even deeper? The next wave of innovation is focusing not just on smart disassembly, but on using materials that are inherently sustainable, right from their very first molecule.
The ultimate goal is this right here, a closed-loop or circular life cycle. You start with reusable materials to make a device. At the end of its life, you don't trash it, you decompose it back into its core components, which are then used to build a brand new circuit. Absolutely nothing is wasted. And you know, this isn't just science fiction. Researchers at UNIST have already proven it's possible. Using simple, eco-friendly solvents, they've shown that some materials can be recycled over and over again. Can you imagine an insulating gel that can be reused 30 times, or a conductor that can be repurposed 5 times, all without losing its performance?
Now, it's important to understand there are really two different paths to this sustainable future. Recyclable means we recover the materials to make new things. But there's another, equally powerful idea: biodegradable.
So what if, instead of being unzipped or dissolved for reuse, your temporary or disposable electronics could just return to nature safely when you're done with them?
And this is not a dream. Scientists have already demonstrated flexible transistors built on a cellulose-based material, which is essentially a kind of paper.
And when they placed these devices in water-rich soil, they completely decomposed in just 19 days. Gone, leaving nothing harmful behind. All of these incredible innovations, the unzippable circuits, the closed-loop materials, the biodegradable components, they're all part of a much bigger philosophical shift. It's really a revolution in how we think about making things, and it's called recyclability by design.
And what that means is that what happens to a product after its useful life is no longer an afterthought. It's a central design question right from day one. It means co-engineering the materials, the device structure, and the recycling process all at the same time so they work in perfect harmony.
The crucial point here is that there's no single magic bullet. It's a complete framework. It requires chemists designing recyclable molecules, engineers building modular devices, and governments creating policies that actually support this entire circular system.
Which brings us right back to our opening question. The technology exists, the path is becoming clear. The challenge now is to choose to build a world where our technology is as sustainable as it is smart, where our gadgets don't just fade into obsolescence, but are reborn again and again.